The figure shows a Z section, and it is required to find the direct stress due to bending at points 1, 2, 3, 4, and thickness is here 2t, here thickness t. Okay, so we call this as a flange, top flange, bottom flange. We call this as a web. So in the problem it is given that the bending moment is acting in the plane of web 2, 3. Bending moment is acting on a plane of web 2, 3. Okay, so the web is a vertical one. Okay, vertical member. So if a bending moment is acting on a vertical plane, is nothing but mx. Okay, so bending moment acting on a vertical plane is nothing but mx, which means that mx is given. Okay, mx is given for us from this bending stress expression. Mx is given. So my is 0. You can take it as my as a 0. So mx is given. Mx is given as mx. Okay, no loads, nothing. Okay. So now we have to find ixx, iyy, ixy by locating the centroids. Okay. So as I told you in the previous classes, we have to divide the given section into the, sections 1, 2, 3 to find x1, y1, something like that. Okay. So now let us divide the given sections, given z section into individual sections. Like let this be section 1, that is 3 to 4 is the section 1, and this is section 2, 3 to 2, and this is section 4. Okay, 1 to 2 is a section 3, okay, section 3, okay, got it? Section 1, section 2, section 3. So now let us calculate the area for these three sections. A1, okay, A1 area of the section 1 is h by 2 into 2t. Okay, it's nothing but ht. A2, the vertical one for the web, 2h into 2t is nothing but 4th, and A3, area of section 3 is h into t or th, whatever it is. Okay, th. Got it? So now let us obtain the x1 values, x1 for the section 1, x1 for the section 1. Let me treat this point as my reference point for finding x1, y1 and so on. Let 4.4 be the reference point. This is section 1. So x1 will be off of h by 2. So x1 is equal to h by 4. Okay, x2 is equal to. So this is centroid here for section 2. So from here to here, treat this as a line. Okay, so x2 is nothing but h by 2. x3, section 3. Okay, total h divided by 2 will be h by 2. So from 4 to this midpoint will be h by 2 plus h by 2, which is nothing but h. And y1 is equal to, so as the centroid is for this section is here, this is our reference point, treat this as a line, so y1 will be 0. And y2, this is a centroid for section 2, this is our reference point, so 2h divided by 2 will be h, and this centroid is located below our reference point, so y2 is nothing but minus h. y3, so this is centroid here, this is the reference point, 2h below the reference point, so y3 is equal to minus 2h. So a1, x1, y1, a2, x2, y2, a3, x3, y3 is available. X bar is equal to, okay, so a1 into x1 plus a2 into x2 plus a3 into x3 divided by sum of all the areas. You get x bar to be 0.625h. Okay, and y bar is equal to a1 y1 plus a2 y2 plus a3 y3 divided by sum of all the areas. Y3 is minus 2h y bar is minus h, not y3. Y bar is equal to minus h, y3 is equal to minus h. minus h. Okay, so now let us locate the centroidal axis, the centroidal x axis. So y is equal to, y bar is equal to minus h. So below the reference point 4, okay, that is off of the web height, your x axis is located at a distance of h by 2. At a distance of h by 2, and from the B point, at a distance, from point 4, at a distance of 0.625 h, our y axis is located. At a distance of 0.625 h, at a distance of 0.625 h. Okay. Okay, 0.625. This is 0.325, 0.625, somewhere here. So this is y axis. Okay, so this is our centroid. Okay, so this is our x axis. Okay, so and this distance is nothing but 0.625 h. Okay, 0.625 h. So we have located the centroidal x-axis and y-axis. Centroidal x-axis and y-axis. Right. Got it. So x-axis, y-axis located. Now we have to find ixx, iyy and ixy. Then the moment of inertia with respect to centroidal xx axis. With respect to the centroidal xx axis. Okay. So ixx, as we know, bd cube by 12 plus area into y minus y bar the whole square. Okay, y minus y bar the whole square. For the section 1, bd cube by 12, h by 2. Okay, h by 2 for the section 1, h by 2. Okay, b d cube by 12 plus area of section 1 is ht into y1 minus y bar. y1 minus y bar. So y1 minus y bar. So minus to minus plus. So I can make it plus h square. So this is for section 1. Plus section 2 again bd cube by 12. bd cube by 12. Okay, 2t into 2h cube by 12 plus a to area 4th into y2 minus y bar. Okay, y2 is minus h, y2 minus, y bar is minus h again, minus into minus plus h whole square. Plus the third section, bd cube by 12, bd cube by 12 again, bd cube by 12 means h, t cube by 12 plus a3 is t into h and y3 minus y bar. So y3 is nothing but minus 2h, y3 minus y bar, minus into minus plus square. Okay, so now we have obtained the moment of inertia for the individual sections. After simplifications, we get, and we need to remember again while computing sectional properties, this higher powers of t can be neglected. This is t cube, I can neglect it. Okay, and here also I can neglect it. So I have neglected two terms. So after simplification, we get ixx to be 3.33 th cube. So this is ixx, 3.333 th cube is the ixx value. Now let us calculate iyy. Any doubt? Okay, I proceed with this. Iyy. So the iyy formula is dv cube by 12 plus area into x minus x bar the whole square. X minus x bar the whole square. Okay, so now iyy is equal to, for section 1, db cube by 12. db b cube by 12, 2t into h by 2 cube, okay, 2t into h by 2 cube by 12 plus area of section 1 is h into t, x1 minus x bar, x1 minus x bar, x1 minus x bar the whole square plus section 2 db cube by 12, 2h into 2t cube by 12, 2h into 2t whole cube by 12 plus area A to 4th into x2 minus x bar, x2 minus x bar the whole square plus the third section again db cube by 12, t into h cube by 12, th cube by 12 plus area A3 is th into x3 minus x bar, x3 minus x bar is 0.625 h the whole square, and we need to cut the higher powers of t here, and this is the higher powers. We can neglect the higher powers, it will not affect your result. And after simplification, Iyy is 0.447 th cube. 0.447 th cube is the Iyy value. Now let us calculate the product moment of inertia Ixy. Okay, so Ixy is nothing but area into x minus x bar into y minus y bar. The product moment of inertia Ixy is equal to first section A1 ht, x1 minus x bar, x1 minus x bar into y1 minus of minus plus y bar plus A2 4th x2 minus x bar y2 minus of minus plus h y bar. Then for the section 3, A3 is th, x3 minus x bar, y3 minus to minus plus y bar. So this is the product moment of inertia. So after simplification we get minus 0.75 th cube, minus 0.75 th cube. Okay, minus 0.75 th cube is the product moment of inertia, that is Ixy value for the given section. Now we have to substitute this Ixx, Iyy, Ixy in this expression. Okay. So before substituting that, we need to write down the moment. So moment is, for example, moment is nothing but, I told you in the beginning itself, the moment is acting in the web, in the plane of web 2, 3. So whenever the moment is acting on a vertical plane means it is referred to as mx. Okay, it is referred to as mx. When the moment is acting on a horizontal plane means it is referred to as my. Okay. So in the problem it is said that moment is acting in the plane of web 2, 3. So mx is given. Mx is given. Nothing but mx is mx. And it is understood that my is 0. My is 0. Now let us plug in this mx, my, Ixx, Iyy, Ixy in this expression. You will get the direct stress due to bending expression in terms of x and y. Any doubt? Okay. So let me wrap this portion. Okay, I need some space. Okay, got it? Now when you just substitute, you get the final expression for sigma z is sigma z, that is direct stress due to bending expression for the given section and for the given bending moment. Okay, so 1.078 mx divided by 1.078 mx divided by th cube into 0.75x, okay, 0.75x plus 0.447y. So this is the expression, bending stress expression, 0.75x plus 0.447y, okay, the whole multiplied by 1.078 mx divided by th cube. Now we have to find out the sigma z at the points 1, 2, 3, 4. So the points, so x distance or x coordinate, y coordinate, sigma z, okay, sigma z, right? So how many points we are having? We are having 4 points, okay, 4 points, 1, 2, 3, 4, right? 1, 2, 3, 4. So x coordinate for the point 1 from the centroid. This is the point 1 from the centroid. How much is the distance we have to find? Okay. So already we knew this. This is the 0.625h. This is h by 2. This is h. Okay. So you can calculate very easily h plus h by 2 minus 0.625h means you will get 0.875h. This is minus h. So this is minus h. Okay, y value. Okay. So it is the fourth quadrant. Obviously, this is in the fourth quadrant. Okay. X is positive, y is negative. If you substitute this, x is equal to 0.875h and minus y is equal to minus h. In this, you are getting 0.2255 mx, 0.2255 mx divided by th square divided by th square. Similarly, 0.2 minus 0.125 h and minus h, and this is coming out to be 0.5829 minus 0.5829 mx divided by th square, minus 0.5829 mx divided by th square. Similarly, 3 also minus 0.125h. The y value is h plus h because it is above the x axis. Okay, so the point 3 is in the second quadrant, right? Second quadrant, 0.3, right? 0.3, 0.4, and okay, the 0.3 is in the second quadrant where x is negative, y is positive, and you're getting plus 0.3808 mx divided by th square. Similarly, the 0.4 minus 0.625h, 0.625h into h gives minus 0.0234, minus 0.0234 mx divided by th square. So this is the final answer for the given moment which is acting in the plane of web 23, that is mx. So the diagram shows the direct stress due to bending. Thank you.